Hi and welcome to another video. This video will be all about the Maxwell Boltzmann Distribution Curve. Now, the Maxwell Boltzmann Distribution Curve was the brainchild of James Clerk Maxwell and Ludwig Boltzmann. The curve was used to prove that when temperature increases, the number of molecules with energy greater than activation energy increases. Now let's look at our Maxwell-Boltzmann distribution curve, whereby the y-axis was the number of molecules and the x-axis was kinetic energy. This is a bell curve, and as you can see over here, towards the right side of the x-axis, the activation energy is labeled. So firstly, what information can we retrieve from the curve? It would be the total area under the curve, which is equivalent to the total number of molecules present in the reaction. Next would be the shaded area under the curve, which I have labeled as B. This would represent the number of molecules with energy greater or equals to the activation energy. Now, what about this region A over here? In this region, molecules have energy less than the activation energy. Therefore, it is highly likely molecules in this region will not be converted into products, because for an effective collision to occur, molecules must have the minimum energy for reaction, which would be equal or greater than the activation energy. Next, let's look into what happens when temperature increases. So let's say we have two temperatures T1 and T2, and T2 is to be higher temperature than T1. How does the bell curve changes? When temperature increases, the curve is pushed to the right as shown. So the curve in green would be the curve for T2, which is at higher temperature than T1. As you can see, the curve T2 is shifted to the right, and this is because the average kinetic energy of reactants increases when temperature increases.
Also note that by increasing temperature, you do not change the activation energy. Therefore, the position of activation energy remains the same for T2.
From the T2 curve, it is also visible that the area under the graph after activation energy has increased. Therefore, we can conclude that more molecules have enough energy, that is greater or equals to activation energy, to react at higher temperature. This is important for rate of reaction, since the rate of reaction will now be higher due to more effective collisions occurring. So as a conclusion, if you are required to comment on these two graphs, you can say that when temperature increases, the average kinetic energy of molecules also increases. Therefore, more molecules now have enough energy, that is greater than activation energy, to react at higher temperature. Thus, more effective collision occurs and the rate of reaction is higher at higher temperature. That's all. A brief explanation on how the Maxwell-Boltzmann distribution curve changes when temperature increases. Thank you.